on APIs and of common application patterns which we used in the past and which are still used on AEM as a cloud service. And I will also discuss a little bit how this reflects into your application and how you should take care of and how what you should pay attention to when you design your application or when you migrate an already existing application which was running in the past either on AEM on-prem or in AEM in Adobe Managed Services. So my name is Jörg Hoh. I'm working now for more than 10 years with AEM and CQ5 before, and I recently switched from a consulting role into the AEM engineering and working there as an SRE. Okay, so let's start. So when we talk about high availability in the context of AEM, we have two approaches. First of all, the farm approach and then the cluster approach. The farm approach is something we are using for a long time, majority of the cases for publish. That means we have a lot of AEM instances and each AEM instance has a repository assigned to it. This approach is used for farming as well in AEM as a cloud service. And then we have cluster. Cluster is not a really entirely new concept. Clustering was possible starting even with CQ5, but also in AEM 6.0 it was possible to cluster with either a database or a Mongo. But with AEM as a cloud service, basically everyone has now a cluster. And the interesting and the most, the part which clustering approach differs from the farming approach is that now you have many AEM instances talking to a single repository. And they do not only read, but they also do write. And that's the main thing, because this comes with some consequences. Because when you write, you got events from the repository. And this has the impact that when you do a change on a single cluster node, it can trigger changes and change events on other cluster nodes as well. And to make it even more complex and interesting, everything is eventually consistent, meaning that it's not happening entirely at the same time, but they're catching up eventually to a consistent state in the repository. So what does it mean and what are the consequences? So the first thing is when I'm hitting AEM, I typically go via load balancer, and then I'm hitting a random AEM instance, the load balancer choose for me, and then I do my modification on the page. Well, that's all good and fine, but now all the other AEM instances are catching up. They catch up with a delay of up to 2 seconds. It's a so-called sync delay. And so what does it mean? Assuming that I do a post and I do a reload of the page, of course I want to see my change event immediately. That means the load balancer should not point me to some other AEM instance, but it should point me to the same AEM instance all the time. So I think in previous times we called this session affinity. Here we use affinity cookies as well, in the same way as we used to do it in the past. It's called affinity cookies and make sure that the load balancer directs you always to the same AEM instance. It's not really a guarantee because this AEM instance can basically go away at any time, but the load balancer says, well, as long as this AEM instance is there, we will direct you there, saying, okay, this helps us to ensure that we get the same access to the same AEM instance all the time, and that we see our changes which we just made, and we might not see, okay, this is the change we made is there, and then we do a change, and then we read again. Oh, this change is not there. We reload the page. Oh, yes, the change is there. That's the use case which we're trying to avoid, and where the use case where we need to have the affinity cookies to ensure that we do the stable routing. So concurrency in an AEM cluster actually hasn't changed, even compared to a non-clustered AEM instance. There are the same rules apply, and I hope you are all got used to the same rules since, well, AEM 6.0. Because since then we have the MVCC pattern, that means concurrent updates do not get visible to other sessions unless you really request it. Because typically just at the end of the lifetime of a session, when you do a save, it's typically the last operation, they are merged. And another thing is, which has been there forever, expect that you get invalid item state exceptions when you change things concurrently. So how does it look like? Assuming you have a repository state, which, to make it easier, I just call head as we called it in a version control system. And then we create a session. This is a session 1. We modify page 1 and we save it, and it will be merged back. It's all not a problem. Everything is working well. So now what happens when we create a session 2 and a session 3, and they can live on the same cluster node, they can live on distinct cluster nodes. They're both modifying the same. And the thing is that first come, first serve, the first one which does the save, that change will get merged. And the second one will just get an invalid item state exception saying, well, this has been already changed. In Git, you would call it a merge conflict and you need to resolve it. Typically in an AEM world, we don't resolve these. We just drop it and ask the user to try again. So these are the same rules as you would get in any non-clustered environment. Here, in a clustered environment, it's sometimes more likely that you will get these things. We'll come back to the first reason would be that you are executing the same operation on many cluster nodes. And the second thing is that sometimes due to the sync delay, the time window can be a little bit larger. That means in a case where you say session 2 is actually finishing up before I open session 3, in a cluster, it still can be parallel. That means that the session 2 has not yet committed a change from the view of another cluster point, and the session 3 is already open, although looking from a global clock, they're not really in parallel, but from a cluster point of view, they're happening in parallel. That means you will get this invalid item state a little bit more often if you don't pay attention to this eventual consistency thing. Another thing which is very interesting when you work with a cluster is that you have one event and multiple event handlers. It means I do my change on the AEM instance, it's writing back to the repository, I get an event. JCR observation event, Sling ResourceChange listener, whatever. You will get this, and in an eventual consistent world, you will get the same event on every other cluster node as well, with a little bit delay, but you will get that. First of all, it might not be a problem, depending on what you're doing in this event handler. Problem could be when they all do the same. When they all want to update something, an entity which exists only once. They all want to update another node in the repository. They all want to update an external database. In this way, in this type of situation, you need to pay attention to the event handling. You need to be aware that you just do one change and a lot of event handlers are starting, can start, and you don't even know how much. because the number of AEM instances is in the cluster in AEM as a cloud service, well, it starts with 2 and basically has no upper limit from a conceptual point of view. So this is the thing which I think I saw most as a problem when you come from an application which was running previously on a single cluster node. Just a single AEM instance you have on AEM on-prem or on AMS. So when we deal with this thing, with this situation, what are the options you have? Because here in this case, assume you want to update a single entity. You want to update an external database with some data that something has happened in the repository. You don't want to have 4 events. You want to have 1 event. And how can we achieve this? And how can we control this? That, well, we do one change, but we don't want to receive n events. What are the options we have? First of all, when we deal with JCR Observation Listener, so by default, you see all the changes in the repository, even the changes made on other cluster nodes. That's the default, and that results in the situation we just described. You handle the same event multiple times. And here in the JCR Observation Listener, you just need to make sure that you don't have any assumption that the local change has triggered this event, which is basically true for every other event handler. It means the change can be synchronized from a cluster, and the actual event has been triggered on some other cluster nodes. And that's a little bit the problem with the JCR Observation Listener, because by default you see everything. So by default you will run into the situation. If you don't revisit all your event handlers, you will get the situation. And how can you overcome this? Well, it's not that hard, because there is a utility thing which allows you to just listen to local events. This is an extension of the JCR API. It's a Jackrabbit event listener, and you need to register it on a Jackrabbit Observation Manager, which are basically drop-ins, replacements of the JCR Observation Manager and Observation Listeners, and they're just offering a few more methods, a few more utilities. And this is the thing. That means if you really want to handle this event just once, because you are doing something which just must happen only once in the cluster, this is the way how you do it. And now going a little bit higher in the stack, ResourceChange Event Listener, it's a little bit different. Actually, it's quite confusing because it's implemented different way around. That means by default, you just see local events. And if you want to receive all events, you need to implement a different interface. So the ResourceChange Listener event is you're just receiving local events, and if you want to receive all, implement the external ResourceChange Listener interface. It's a bit confusing because they're one way and the other way on the Sling level, but this probably is more natural, because typically in most cases I would say, well, you might want to handle local events, and sometimes you need to work on the other way. Also, ResourceChange event listeners are not that common yet. Many people just work on the JCR observation, but in any way, revisit all these implementations, because you really need to make sure that you are reacting once or many times, depending on your application logic. And now a few interesting things, because they don't change at all. Sling events, well, they're sitting on top of OSGI events, and OSGI events are by default at the first time they're just local. It means they're limited to the single JVM. There are as a distributed OSGI, but it's something we don't use in AEM. And there is another way to distribute events via the repository, but this is a distributed event admin part of Sling. It's also part of AEM. It means it's shipped with AEM, but I think we rarely use it. If you want to use it, well, add the property event distribute to the event properties, and then the event is being distributed. But by default, all AEM events and so on are just shipped locally and are just sent locally, and that's no problem. Sling jobs, nothing has changed because we have already this exactly once guarantee for quite some time. And this guarantee doesn't go away with the clustering approach. You just have a little bit more flexibility when it comes to distribute the event queues over the multiple cluster nodes. But this is, I would say, this is rarely done. But unless if you're making, well, and even then, you just might have a not equal distribution of job execution in the cluster. Eventually, maybe you just have execute all jobs on a single cluster node, but this doesn't change the functionality. This is just the load behavior of the application. AEM workflows pretty much the same, because it's built on based on Sling workflows, and that's the thing. You create them on any nodes, and they're executed on the cluster leader because that's where the Sling queues are running. But this is something you can just, as said, you can just manipulate. You can just switch the execution between the cluster nodes, but typically we just stick with the default. And the guarantee will not go away. They're executed exactly once. Okay. Another thing is the scheduler. It's also one of these things where you can say, I have one event, let's say passing a certain time, and I will see it, and it's executed in every cluster node. Here, the scheduler is, the fact is that each cluster node has its own scheduler, and that there's only one way to run the scheduler on a single node. I mean, if you want to trigger, let's say, a data import 3 a.m. in the morning, and you don't want to run it twice or 3 or 4 times in parallel, you need to limit it to run exactly once in a cluster, and this is done via this scheduler run on leader thing. Of course, you need to have this definition in all cluster nodes, because otherwise, well, yeah, if you register your scheduled job on a random node and this random node is not the leader, then yeah, the random job this job is not running at all. So the majority of the things, in many cases, I'd say the majority of the cases which are affected by clustering is really repository limited. And these are mostly, let's say, these reactions on events. This is the thing which is mostly causing problems, if it's causing problems at all. Because AEM itself has been cluster aware since quite some time. I think it has been cluster aware since the beginning, although in many cases it was not used. So coming to a few use cases which you should reconsider, possibly. One use case is an in-memory cache, where you want to cache things you have read from the repository, and you don't want to read it over and over again, but just read it from an in-memory cache. Typically, you need to reflect the state in the repository. It means when something has changed in the repository, it should be changing in your cache as well. And assuming that you are creating, that the changes which you are doing in the repository are created on the same node in a single cluster node. In a single cluster node, you might have come to the situation that you say, well, my code creates or computes the change, and I put it in the cache and I put it into the repository at the same time. In the cluster world, this is no longer working, because you might run this computation which creates the thing you put in the cluster. You just might run it on a single node because maybe it's triggered by a user request. And that means you cannot run this approach anymore, but you have to, well, let your cache react on changes in the JCR repository using JCR Observation or a ResourceChange listener. I think in many cases this is not a problem because it has been used most often this way, but sometimes a cache has been tightly implemented into a service which has done something, and that cache was private anyway, so the developer decided for going the easy way, which is totally okay in a single cluster node, but it's not really working in a true cluster with more than one node. So in this case, if you have this type of application, you need to adjust the cache. Another thing is, common thing is execute a task exactly once. There are a number of ways. First of all, if you have a triggering action, which is happening and which is triggering this, that create a Sling job or a workflow. It works very well, and it gives you this guarantee that this is executed only once. The next thing is, well, use a scheduled job when it's really timely. If you can trigger it by time, or always the simplest case is trigger it externally. Let someone do a request to AEM, and then well, create your Sling job, or if you need to have the guarantees of a Sling job, or do the change directly within the context of a request. Okay, so coming to the conclusion. The first thing you need to take away is you do one change and you will receive multiple events. On each cluster node, you will receive the same event. Maybe not exactly at the same time, but you will receive them. And you need to be able to handle them and react on them adequately in a way that is not breaking your application, and in a way that you don't pollute your log files with a lot of invalid item state exceptions. That means you should really check all your event handlers and really find out if it's okay to run this handling of this event on all cluster nodes in the same way, because whatever they do, it needs to happen on all cluster nodes, or if this needs to run exactly once for the whole cluster, because in that case you need to change your code. Because when you are coming from a single node cluster, well, it's the same semantic. Runs on the same node, yes, needs to run on the same node, and needs to run on the cluster exactly once. Well, that's totally identical. The next thing is this eventual consistency. It can be a fun thing because you might run into interesting type of errors when you don't follow this thing. That means you need to really attach your affinity cookie. The little story I have is that we were running into quite some testing problems because sometimes the testing clients were using different HTTP clients, which did not share their cookie store. And that means that we were hitting the same cluster. We were hitting different cluster nodes in a test, while their test cases were expecting, well, we're always reaching out to the same cluster node, and I can read the change I just made. And it was a little bit hard to really track down because there were some other things which made it a little bit harder. But when you do this, when you do requests from externally to AEM to do whatever you want, could be anything. in a cluster, really respect that affinity cookie and use it, and make sure that you're reusing it, because in other ways you will just end up eventually on different cluster nodes, and that's probably not what you want. Okay, so that's all on my side. In case you want to reach me, it's probably the easiest way would be Twitter at Jörg Hoh, my handle. And also there will be my blog. I'm posting, I would like to post more often, but I sometimes don't have really the time for it, and sometimes maybe not the right topics. But it's always, I hope to will hope to continue to work on this, to post more and provide more updates on it on a regular basis. Okay, thank you for joining here. Now let's switch over to the Q&A part. If I see it right, there is no question posted right now. Maybe give you a few seconds to come up with some interesting questions or drop them in the chat. Daniel mentioned that this, yeah, he should have had this 6 months ago. Yeah, it's could be always the case that you knew things a little bit earlier. But well, now at least you have it. Are there more questions? Five. Oh, there is one question. Oh, Chris asked, well, answer now. Chris is asking if I could describe the main difference between farming and clustering with respect to event handling. Okay, let me go to the first slide. And here it is. So in case of clustering, all these cluster nodes share the same repository. That means if I do something on cluster node 1, a change in the repository, the cluster node 2 and 3 and 4 and 8 and 10 get the same change eventually as well. That means they get the change, and the JCR says, well, when there is a change, you will get an event for it, or you can register for an event for it. And this is causing, I think, the main difference, because in a farm, well, each AEM instance has its own repository. It means if AEM instance, if publish 1 does a change in the repository, publish 2 will never see that change. And of course, they will never throw an event. And that's the main thing here in the AEM. In the cluster, one node will change something and the other ones are able to access this change, to see this change. Okay, so now let's mark answered. Robin is asking, in AEM as a cloud service / AEM on-prem, is the cluster leader determined automatically by the cluster itself? Yes, by the cluster. When you say that it's, let's say AEM, if you say cluster equals AEM, technically there is it's a Sling service which is doing the cluster lead, detecting the cluster leader versus from all the available cluster nodes. It's a Sling. I just forgot the name. Sorry, but it's a feature which is available there. And of course, AEM on-prem, when you have a cluster, you will have this service will working as well. It will even run on a single node cluster. That means a single AEM instance, but that's optimized for this case that it basically doesn't do very much, but the code is actually there. Okay, I think we are at the top of the hour. Oh, well, no, I have a little bit of time because next starts in about 9 minutes. Oh, yeah. Thank you, Carsten. Sling Discovery. Are there any more questions? I don't see anything in the chat. I don't see anything on the Q&A part. Oh, still one question. Always on the last minute. Chris was posting an if you had workflows in a publish instance in farm, but in a cluster, the workflows run on the leader. Does it mean workflows in a cluster usually run on author instances? I'm not sure if I get the question right. Let me clarify one thing first. In AEM as a cloud service, we have an author cluster, and the publish are in a farm. It means no publish and author are never in the same cluster. It means if you have a cluster, you have an author cluster, or technically you could create a publish cluster, but it's not able to mix these things. No, don't do this. Don't try this out. And this means here workflows in a cluster. If it's an author cluster there, well, yeah, it's author, and on publish, technically you can run workflows on publish as well. But then when you do have just a farm, you have running the workflows on each AEM instance, and there do not know what's happening on the other instances in a farm approach. Oh, Daniel was posting, and Ollie. Oh, okay, we'll try to get through them. Daniel is asking, in case you want to trigger a Sling job based on the resource change using a listener, is there an additional manual check we need to do not to start many jobs of the same type? That's a really good question. Well, take care that you just, when you say you want to handle it, when you want to handle a single change in the repository, and assuming you want to use a ResourceChange listener, make sure that it's just receiving the local events. That you mean that you create the Sling job on the cluster node where this event did happen. And in that case, you may just want to either use a JCR observation, or in case you want to use a ResourceChange listener, use the standard ResourceChange listener, not the external one, which is able to handle all events. But that's a really good point, Sling, and this can cause many interesting type of errors and polluting your logs a lot, because when you have create 4 jobs dealing to update the same node, you will see a lot of exceptions until the last job eventually, well, basically every job will work and continue and finish eventually, but at every fight, there will be 4 fighting for a single node, and one will win, and the other one jobs will be restarted at a few seconds, and then there are 3 jobs competing to do the same change, and one will win, and 2 will be rescheduled, and then 2 are fighting, and one will win, and another one will eventually do this final thing, but in the end they're all doing the same change. And sometimes this can work if you're just doing an idempotent change, but if you just read a value and update it, maybe you just, well, it's not working well. You get something, a result you don't expect. How are events from asset service populated? Ollie is asking this question. I think, Ollie, you mean asset compute. And in case asset compute, well, it's it's an implementation detail, and I don't know the very details how it's done. But for example, when the renditions have been created, you get the same events as you would get when you run AEM 6.5 on-prem, where everything was running within the virtual machine. So the events are basically the fact that the renditions are created externally is totally transparent for you, and the adapter between AEM and the asset compute service will create these events for you. Okay, still 61 attendees, and we're close. Still, we could get one. We could still get some question answered, no problem. But I think I will stick around here for the evening, and well, you can always approach me. Oops, not the one. I think I should really finish now. But this is here where you can reach me. Ping me on Twitter, drop me a question on the blog, or reach out to me via the chat. I'm there. Okay, then thank you and have a nice evening and a great day 3 of the adaptTo tomorrow. Bye-bye.